video problem. It's not there.
At Datameer, a provider of a business intelligence platform for Hadoop. So if you haven't heard of us, that's what we do. We provide a native Hadoop-based business intelligence and analytics platform for end users. So we'll talk a little bit about the changes in the current state of the landscape of data that people are trying to analyze with Hadoop and tools like Datameer. And then also talk about this concept of just-in-time analytics or a just-in-time data supply chain. So you'll hear more about that as we go through the talk. So first, a bit about the backdrop that we're operating against. Again, some of the observations I've taken away from my job as I said, I'm working in the field with customers every day. We have several dozen customers, and we have all the different data. We use all different Hadoop sub-projects, Hadoop distribution, and other NoSQL technologies. So we've seen a lot of things in the field. We'll talk a little bit about the solution that we offer and give you a guys a demo as well. And the demo might involve using your mobile phone, FYI. Okay. So first of all, the landscape, kind of the context in which we're all operating is bringing us here and driving kind of the market today. I think it's pretty clear for most of the people that work in Hadoop, it's about the three things that the analysts will tell you: volume, variety, and velocity of data. So certain data is growing exponentially, other data is growing as well. Unstructured data in particular is growing much, much faster, and customers have companies have a much more strong mandate to be able to understand that unstructured data. The interaction data is generated that's less and less accessible to them, and that results from the fact that they don't have touch points directly with their customers. They don't have visual touch points with their customers. There's also enormous pressure to be able to scale data management tools, data warehousing tools, big data technologies, whatever you want to call them, economically. So that cost per terabyte kind of ratio makes sense for most companies. But they also want to be able to maintain agility, right? So I'll talk a little bit about that later in the talk, but the way I would define that, your agility or your time to insight is when a new piece of information that you've never analyzed before, or a new set of data, a new source of data comes into play, how long does it take you to actually get insight from that data? So that's what I'll call time to insight. Obviously, the dramatically dropping cost of storage and CPU that's available with commodity hardware that Hadoop obviously leverages completely is driving this disruptive new technologies like Hadoop, the ability to rent machines and just deploy something in the cloud very, very quickly without owning the infrastructure yourself is driving it. And I think also a general sort of awareness and awakening that the companies need to access all of this data, and the best way to do that is to sort of crowdsource those insights. So in other words, the data should be ubiquitous. Anyone should be able to work with big data, not only data scientists, and it should be as accessible as possible, and you should be able to implement just-in-time delivery of those insights. So in other words, as soon as there's a change in the business requirement or thought that a new type of data is relevant to the business, there should be a very, very short delay in rolling out that data to the business. So that's kind of the background that we're all operating in, and Hadoop is a disruptive and very powerful response to that backdrop, to that landscape. And it does a lot of things. It doesn't do everything. It obviously solves the scale problem. It solves the flexibility problem or the variety problem. It's extremely economical. It has some challenges in terms of the level of complexity. So what is the barrier to entry today? And one of the things I would posit is that the barrier to entry for working with big data is a little bit too high today. You need probably too many skills and too much technical expertise to be able to work with big data directly. So the other real problem is there's a lack of packaged applications. So that's changing as more and more startups are funded. And as you may have heard, folks like Platters talk about, they're really pushing this concept of developing an ecosystem of applications on top of Hadoop, but it's very sparse today. Despite that, we see an enormous amount of adoption. Obviously, it was led by folks at Yahoo and Facebook and other large web properties, but it's really almost any Fortune 500 or Global 2000 company today, somewhere within the organization, you'll find at least a nascent Hadoop project with 5 or 10 nodes all the way up to thousands of nodes. So that's kind of the backdrop. And the current state, I would say, is that we're in the process of solving all these problems with big data technology and what some would call an operating system for big data that Hadoop is becoming as all the sub-projects mature. But we're not quite there yet. So I would say that, first of all, the volume problem is solved by Hadoop, but it's also solved reasonably well by other MPP databases, other massively parallel databases. So there's things out there like Vertica and Astrodata and Greenplum and so on that actually proceed and do that can handle very, very large scale analytical problems. And I would also argue that sometimes for folks who are not initiated, who are not really familiar with Hadoop and don't have the right skill set in organizations, they might actually get a lower cost of ownership out of one of those systems, depending on the type of problems that they're solving today. Although those systems don't handle variety, right? Most of them are still designed for structured data, rows and columns, SQL as a tool for accessing them. They don't work well with machine-generated data. They don't work well with textual data. The variety problem, integrating into those other sources, is solved by Hadoop, and is tractable with Hadoop. I think in terms of velocity, in other words, being able to ingest at very high rates from a very large number of sources and servers in a reliable way is still a struggle for a lot of companies that we see today. Some people do very, very well. Others are struggling. I'll talk about some of the ways that they're struggling. And going back to what I mentioned before, I think the time to insight measurements, again, when there's a new piece of data, think of a new field, or a new data set, a new table, if you will, or a new type of file structure, or a new social media feed that you want to plug into your pipeline, what's the delay in actually getting insights from that data? And I think that's considerably high for those companies who are really just operating in terms of classical ETL paradigm, where a developer codes something, make sure that it meets the business requirements, and then the business user has a data mart or some sort of access to the data to work with it. So the question is, if that time is increasing significantly, is this actually lowering the agility of companies who work with big data technology? Because it's they're very powerful, they're very flexible, but they're also very programmatic, program intensive, I would say. So talk about the solution in a minute. First, just some of the observations about the data itself, the types of data that we see in our clients, and the state of readiness for the clients, and the state of sort of their expertise and proficiency in working with it. The first thing is that we're kind of still in the Wild West era for big data formats. So how is data structured? We're also dealing with a lack of expertise in a lot of our customers in how they do ingest, how they store data, how they actually collect data. And this is not to say that dozens or hundreds of companies haven't figured this out well, but there are some folks that are still struggling. In terms of the content of the data itself, we see a lot of interesting things that cause customers to trip up. And this is particularly the case as they move forward with ingesting social media data. So thinking about Facebook data in particular. And then the other things that we're seeing is sort of this gold rush or rush to judgment about how important it is to understand a certain silo of data or a certain category of data like social media without really thinking through how well that data correlates or joins with other sources that we have in our compute file system or in our data warehouse, wherever that might be. So just as with sort of web analytics, we see packaged applications in the cloud, Google Analytics, you have Omniture, those sort of things where you can put an ether on your page and send the data over to that provider. But how do you really correlate that with the transactional data you have in-house on-premise, right? So I talk to customers all the time who have this problem. It's the same problem we're seeing with social media data as well. One anecdote in particular is a customer working with Omniture, and their interest was in doing marketing channel attribution. So they're trying to understand from the clickstream data that they have, what are the top referring websites that drive traffic to the site? Well, that's a pretty easy question to answer if you have a Google Analytics or an Omniture. But how do you translate those sessions that are coming from the various channels into actual dollars sold? So how do you actually correlate the value of each incoming session from that marketing partner to what was purchased and the total dollars that your participation with that partner brought you per month or quarter, for example. So drilling a little bit more into some of the observations I talked about data formats. Obviously, we're seeing a lot of people storing JSON or collecting data JSON from places like Twitter, Facebook, so the public APIs of those giving back JSON data to measure, what were the number of check-ins in those places, your friends, your likes, all that data is JSON-based, as well as tweets and MongoDB, of course, being one of the more document-oriented NoSQL databases that keeps JSON as its persistence format. So we see from various sources kind of dirty, messy data. It's not always necessarily well-formed. It makes it difficult to do things like automatically splitting data. If you have data that's uncompressed, you're trying to split a large file with the MapReduce job. There's no tag at the end of that section that says you're at the end of the XML element, so therefore you know where to split your records. You just have a whole bunch of curly braces and square brackets to deal with. So there's some challenges there, both in the formatting of the data and how to process it well. And we see a lot of people using sequence files, obviously kind of the first file format defined explicitly for Hadoop, with built-in compression, built-in splittability, some advantages there. It's a little bit difficult for new developers to figure out what's in that data, what are in the actual files themselves. There is a provision for adding metadata to your sequence files, but it's very, very open-ended and not a lot of people use it. So you can add a header to a file that says, here's what's in it, but what's in it is just a bunch of key value pairs. What does that actually mean? Are there actually that number of fields? What's the type? How many characters for each of the fields? How is it organized? It can be anything. So it's not great for interoperability between development teams. We also see people really packing a lot of different things into sequence files just sort of per default because that's the easiest thing for them to do. So for example, we see things like people putting sections of compressed files into sequence files and then compressing them again. We see people packing things like JSON, which is generated by Flume. So if you think about that, if you kind of unpack it, you've got a file with a key and a value structure. So that's great. So you can look it up by the key. Inside the value, it can be anything. In this case, it's a JSON record. So it's text that you got to parse. And then you've got some fields within that. And then within that, people are putting really complex structures of data or even binary data. That again kind of obfuscates it a little bit. The other thing we're seeing is people just load their data raw, because that's actually the simplest thing to do if you're just getting started with Hadoop. Well, I'm not really sure what's going to happen with Avro, I'm not really sure about sequence files, so I'm just going to dump my data raw and deliver it to text format, and it's the delimiter of the week, and it changes all the time. And there's a lot of other problems about how it's stored, but we see challenges just in not knowing what the text encoding for this file is, right? Not knowing what kind of crazy delimiter is being used. We've never heard of the thorn character, so I've run into that problem a couple of times. So that's the data formats piece of it. In terms of ingestion, I think I mentioned before that this is where I see a lot of people still struggling at dealing with the velocity of the data. So how do I collect data in an efficient manner? If it's my very first time using the Facebook Graph API and collecting my Facebook friends from all my customers who have signed up for my Facebook-enabled application. I see people collecting one record per file, which many people know in the big land is probably not a great idea. And how to define what is your policy for sort of storing and forwarding the data at the collection point into Hadoop. Do I really need guaranteed delivery? Do I really need that data to be in Hadoop in real time within milliseconds? If I'm just going to run a batch job, it's going to give me the results of my analytics in 10 or 15 minutes. So what really are the requirements for durability and your SLA for actually getting insights out of the data? And then I see a lot of people generating enormous amounts of files, collecting files per minute or even every 10 seconds, generating a huge amount of files of view, but then not going through and compacting that into something that's reasonable for analytics. Do you need to run queries on 10-second slices, or do you really need to run queries, on days of data? What's the average sort of length of the range of data that you're going to scan? So compaction is obviously something that is useful at the more sort of mature, new deployments lets you do that. And then how is the data going to be partitioned? So it might be easy to collect that data and just store it based on the server where it originally came from, whatever was feeding into Hadoop. And we see all sorts of different types of projects. People using Glue, Stripe, things like Kafka, for example. People looking at NP series with Hadoop. But how do I actually then structure that data with a partition or just a feed of sequence file? Or how do I bucket the individual files? I think I should be doing that in a way that's reasonable for actually the analytics that I want to do. So what are the dimensions that I want to do analytics on? Maybe or maybe not the actual server that the log entry came from. And then how about storing the data? So again, when people first start out with Hadoop, you see a lot of it. As we're not dealing with necessarily the early adopters of Datameer, we're dealing with people that are kind of an early majority, if you will, of the hype curve, who are just now beginning to install their first Hadoop cluster. And so, as I mentioned, one of the first instincts is to store my data in raw, delimited text, uncompressed, even if maybe a lot of that data is numerical. I'm not getting most efficient storage there. I'm obviously not compressing it, which is going to slow things down. Or I'm something I just heard about yesterday. I'm going to put my data in sequence files just because that's the thing to do. But I've got 64 megabyte blocks, and then I've got 200 megabyte files spread across the different blocks, and the file within that is actually compressed. So if you think about how would you actually have to process that, you have to go and read through all 200 megabytes of that file, 4 different blocks on the Hadoop file system, decompress the underlying file, right, and then load that into memory into one of your mappers. So basically, you'd be losing all the parallelism that you're trying to achieve by doing that block storage. You'd be running one mapper against these 4 different blocks. And then there's just some maturity in sort of the APIs that's coming along. But if you look at things like the way people are using LDO, there's a lot of mixing different concerns within various APIs. So compression codec, the way that we split data, the fact that this is actually going to be a single line text record, all those 3 assumptions are made in that one class right there. And what if you want to switch your compression codec tomorrow because the new one comes out? It's been hard coded into the system, right? So that's what we see in terms of collection, ingestion, storage, and so on. And then in terms of the data, obviously, it's getting more and more semi-structured. It's getting more and more, I would say, verbose. So there's huge amounts of data packed within structure that you might think would be smaller. Talk about the Facebook data a little bit. And I've seen people just getting started, for example, with the Facebook data saying, I want to get all the friends that are attached to this particular Facebook user and blow up their tasks because they just tried to transpose their data and ran out of memory. And then obviously, if you're doing any sort of text analysis or sentiment analysis and you're collecting data from these social channels, obviously that's going to be difficult if you're in multiple languages. And yet people try to apply some simple simplistic methods there. So if you look at this, I mean, it's a lot of noise, and it's not necessarily a lot of signal. This is a Facebook profile returned from the Graph API, and there's a lot of nice regionally structured information there at the bottom that's very useful for a marketer, but somebody's favorite quotes may or may not be interesting. That's taking up more than half of the record that you see here. We also see people analyzing email data with Datameer email archives. If they're pulling emails out of their CRM system, for example, or their mail servers, they're analyzing the text of the email. There's the email, it's actually went to the Hadoop mailing list, and those are all the headers above that. So again, it's a lot of noise and not a lot of signal. So signal and noise ratio issues that people are dealing with. So what do we need to handle sort of all of these challenges? What we would call that is a just-in-time data supply chain. And remember, I talked about time to insight before. Basically, just compressing that down as much as possible. So a new piece of information, a new source of information, a new data set comes online. How quickly can you get answers? And I don't necessarily mean the MapReduce developer in this case. I mean the business person who has the question, who drove the requirement to integrate that piece of data into your pipeline. How quickly can they get the answers that they're looking for? So the classical data warehousing method looks like this. 3 different components of the system. It has a lot of maturity. It also has a lot of drawbacks. And Hadoop, as many of you know, enables this concept of sort of schema on read. So you reduce the bottleneck in the first phase, which is the ETL process, by loading your data raw. You don't create a heavy schema. You don't index when you insert. You don't transform your data heavily on a vertically scaling single node ETL solution. Just push it in raw. And you can even use Hadoop itself to pull that in a distributed fashion. Then you store your data. It's miles cheaper than anything else that's in the market today. In terms of cost per terabyte, we're looking at $300 a terabyte to store and process on Hadoop. But then you enable what's probably the most interesting part, which is model upon read or schema upon read. So I use sort of the brute force computing power of Hadoop to transform the data into what's business relevant, as opposed to doing that up front, paying the computational cost up front when you write the data into the warehouse. In other words, after it gets ETL'd into the data warehouse. So that's actually a really, really powerful concept, and it's probably the most important thing that will improve agility rather than reduce agility. Now, on the other hand, if you do this, and your schema on read is a pretty pre-read process just to get a new MapReduce out the door, then you haven't necessarily improved things. Again, you solved the volume problem. To some degree, you solved the variety problem. You haven't helped agility. You haven't necessarily dealt with velocity. So what we're trying to do is really compress time to insight as much as possible by putting those 3 capabilities, those 3 functional capabilities, into one tool and make it sit on top of Hadoop and leverage Hadoop throughout the entire pipeline. Keep your data in one place as well. So it's a business intelligence and reporting solution built natively for Hadoop from the ground up. You guys may have heard of us. We're at datameer.com. And you can learn more on our website. I won't bore you too much with the product spiel. We also have done a lot of effort, though, to kind of insulate people from the changes, both in the way they store data and actually the Hadoop ecosystem as well. The Hadoop ecosystem is evolving really, really fast. There's lots of new distribution vendors out there. There'll probably be more. They'll be evolving over time. We certify our solution on top of all of them, and you're basically insulated from any change that might occur in the market. So anything that you develop in Datameer will run into those. And it'll also leverage sort of your investments in existing relational technology. All those things can be integrated seamlessly to the pipelines so you get data in Vertica, Greenplum, or Oracle, or what have you. Or NoSQL like Cassandra. You've got some data in the niche base 5, what have you. And also trying to make sure that for those large organizations who have existing identity management systems and monitoring tools, that we kind of fit in with the way their operations team expects the system to work. So that's a little bit about the product. And I'll go through a little quick demo right now, and we'll talk about sort of this semi-structured data and how we can really, really efficiently deal with that change. So this involves some Facebook data. And it might be actually something that we can do sort of ad hoc in real time. So my name on Facebook is Matt Schumpert. Probably the only Matt Schumpert on Facebook. If any of you guys want to friend me and perhaps check into where we are right now, which is the Yahoo URLs Cafe, that might be useful in the demo in a minute. So let's have a look at some of the data that we're going to work with here. Okay, so this is Datameer, by the way, in case you were wondering about that. So we have a couple of data sets that we brought in and that we know are useful to us. And all this data revolves around Facebook. So what you're looking at here, kind of the first tab within the workbook is our profile. What we're looking at in subsequent tabs is other elements of data we get from Facebook. So when I say that I like something, when I say that I have friends, who are my friends, when I check in somewhere, etc., etc. And what we've done is we've actually transformed this data and sort of extracted just the relevant components of it, right? There's a lot of noise within this profile data. There's a lot of columns. This might not all be relevant to us, but we've sort of determined that our employment information is relevant to us. Maybe what we've indicated we like and the category of the product that we like at the time which it was indicated. Maybe our friends are important, and maybe the categories of things that people like, and so on and so forth. But maybe what we haven't determined yet is that the education history of our Facebook users is important. So what we can do is we can extract that sort of on the fly, build ourselves a schema on demand, and then integrate that piece of data into the analysis. So this is the format of data in Facebook. It's JSON structure, which can be nested. And so you'll see that there's multiple entries there in the education field. So in order to get at that data, what I'll do is I'll create a new spreadsheet, and then I'll just bring up the formula builder. So it looks kind of like Excel. And I can just grab all the elements within that area of data. So just all of the different various entries in the education field. You can see it's filled out here. And it brings me sort of every school or every institution that I've potentially been involved in for all the users that I'm looking at. So that's the first step. And I'll do a little bit of a shortcut here and just kind of grab some elements from this data set. So the school has a name, it has an ID, it has a type, etc., etc. You can see the structure there, just kind of browse it, and then I can just pull out the elements that are interesting to me. So the name of the school goes over here in column B, and I'm not, defining sorry, I can't name that same thing. I'm not defining like another high table here and defining a petition structure and writing some code or figuring out, well, how should I do my row key in an HBase table to make this analytics work? I'm just sort of doing this on demand as I explore the data. So I'm also interested in the type of institution that this is. So I'm going to extract that as well, which is just called type. And now I've got the type there as well. Okay, so that's the type. What if I need to really look at this on a map? Because I'm not an expert in all these places. I don't know where Singapore is maybe. So I want to be able to put this information on a map. So what I need to do is enrich this data with another source, right? So again, instead of the programming exercise, it's let me just browse to the data that's out there in the public cloud, for example, that has very simple geolocation table for all the universities that exist in the world, right? So now all I need to do is actually join these two things together. So the education data is over here, so I'll rename that education data, and then I'll do my join, and the join will be just a point-and-click exercise. So let's take the education data and all the universities and just join them together on with the name of the school. We don't really need any of these columns here. We just really need the institution name and then maybe the latitude and longitude, right? So now I've got that those universities that exist in that list and the people who I'm looking at went there all in one place. So that's the information that I need to bring together. So we can run that. And hopefully maybe some of you have friended me and checked in. Looks like I got at least one friend request here. Potentially, nope, I got an invite. Okay, well I've got a bunch of friends, luckily, who have already helped me out here. So I can check in, for example, to the URL cafe, but I've actually done that just in advance to kind of figure out how that works. So what we're doing is we're actually going to connect to Facebook and bring in a whole bunch of data about ourselves and about our friends as well. And the way that works is actually through the Facebook Graph API, you not only have access to your own information, but depending on the privacy setting, you do have access to information from all your friends based on their security settings. So some people might allow you to see who they like, some people might allow you to see who, where they checked in, and the policy is the same for the APIs as it is for the Facebook itself. So what we're now doing is, in addition to running the additional analysis that you just saw where I got the location data, I've also pulled in kind of the latest copy of all this information. So we'll have more data, and now it's automatically running this analysis, which, by the way, is running on Hadoop. So this is all the spreadsheets that build are running. In the background is MapReduce jobs, and you can see all the MapReduce jobs proceeding. And then we'll have our results, including the location data. So maybe take a look at some of the things that I already have available. If I bring up this dashboard, you'll see, for example, this actually happened while I was setting up for the talk. Somebody, a good friend of mine, is on Bourbon Street right now in New Orleans. So these are the latest check-ins of a set of friends that I've indicated.